What is Life by Erwin Schrodinger, a seminal work of scientific literature of the 20th century and a book of very intriguing insights and implications. So, you may be familiar with the name Erwin Schrodinger, Nobel Prize winning physicist who is perhaps most well known today in broader popular culture because of his thought experiment referred to as Schrodinger's cat, which is intended to illustrate the concept of the many worlds interpretation of quantum mechanics. But Schrodinger also wrote this: What is Life? A very fascinating little book in which he undertook to analyze the phenomenon of life, of living organisms, not necessarily through the lens of biology, because he was not a biologist, but rather through the lens of physics. Now, this edition of What is Life also contains chapters which are headed under the title of Mind and Matter. And that section was actually of the greatest interest to me personally. But in What is Life, like I say, Schrodinger undertook to analyze the phenomenon of living organisms, of living matter, through the lens of physics. And what's interesting is that a lot of this actually prefigures, I think, the development of the field of quantum biology, actually, and also of very great importance when talking about this work is to mention that Schrodinger effectively predicted and prefigured the later discovery of DNA, because at the time that What is Life was written, DNA had not yet been discovered. But Schrodinger in this work postulates what I believe he refers to as an aperiodic crystal, some type of very, 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 very minute molecule which transmits hereditary properties. And, is responsible for the ultimate development of every individual living thing, that is DNA, which was later discovered by Crick and Watson after the publication of this book. So Schrodinger actually kind of got the jump on some later biological developments, actually, with the writing of What is Life. But also Schrodinger analyzes life from the quantum level. And like I say, a lot of this kind of, I think, prefigures the later development of the field of quantum biology, because Schrodinger illustrates that evolution, in a way, is a quantum phenomenon, because mutations are definitely of a quantum character. Mutations being generally the way that life evolves. But mutations occur on the very smallest of levels, like the very most minute of levels in the genetic composition of living things. And moreover, mutations can be stimulated through bombardment with radiation, such as X-rays, right? That's why, you don't want to get too many X-rays because it has a tendency to, like, increase your chances of getting cancer and stuff like that. And that's because the very, very, very minute particles are interacting with the very, very, very minute components of your genetic material. And because of this, mutations are fundamentally of a quantum character, that life on the large scale is influenced by particles on the very smallest of scales, right? But also, Schrodinger asserts that large scale processes, large scale order, can ultimately rest on disorder on the smallest scale, right? And this is, of course, in keeping with the findings of the field of quantum mechanics, because on our macro world, things are generally quite orderly, right? Cause and effect, is how the world seems to operate. You turn over a glass of water, the water spills, it's very predictable, right? But on the quantum level, that is on the micro level, things are not so cut and dried. Things are not so easy to grasp. And that's because on the quantum level, things are much more chaotic. But on the macro level, they're not. And what Schrodinger is arguing here is that uh, order on the large scale can arise from disorder on the small scale. And as an example to illustrate this, he uses diffusion. Like you take a glass of water and you drop, some dye into the water. The process of diffusion is fundamentally based upon totally random movements of the molecules, right? There is no like order to the way that uh, the molecules move. It's totally random and chaotic, and yet the overall process of diffusion is like observably very orderly. You drop the dye in the water. On the micro scale, it's total chaos as the molecules and stuff are just going everywhere. But on the large scale, you can watch as the dye very, smoothly in a pretty orderly fashion moves to color all the water and spread itself out. And so this is Schrodinger's demonstration that on the large scale things are generally orderly, but that can rest upon great disorder on the smallest of scales. But also another thing that Schrodinger says in this work that is pretty interesting, or that I found pretty interesting, is that life feeds on what he refers to as negative entropy. Now, that's just kind of a fancier way for the physicist to say that life has to consume to persist, right? We have to eat, we have to drink. But this is because, on a physical level, everything is moving towards maximum entropy, right? And so the only reason that our lives persist, the only reason that our bodies keep working is because we have to draw energy out of the environment through the consumption of materials that hold the potential for it, which we break down when in the process of digestion and whatnot to, decrease our overall entropy. And so what Schrodinger says is that life feeds on what he refers to in the book as negative entropy. Again, he uses very physical terminology, terminology that is very intrinsic to the field of physics, but it offers some very penetrating and revealing insights into the way that life actually works, on the most basic of levels. Now, coming over from the what is life section of the book, the titular section, to the other section of the book, which is entitled Mind and Matter, this is where things got really interesting for me, because this is much more loaded with philosophical implications than the first section, I think. It's much more speculative in this section of the work, as he is kind of engaging not only with scientific concepts, but also with concepts from philosophy and religion. And one thing that really struck me in this section is just how shallow the scientists of the present day seem in comparison to the scientists from the past, right? Because Schrodinger was, this does not feel like anything that you would read a scientist saying today. Like, this does not feel like anything that Neil deGrasse Tyson or Daniel Dennett or anybody would dare go so far as to even engage with today, because Schrodinger is speculating very intensively about the relationship between the mind and the world around it. He engages a lot with like the philosophy of Kant, and he also kind of says that there is a needless distinction there in the Kantian system of philosophy between phenomena and noumena, right? What Schrodinger actually adhered to, or at least seemed to adhere to, was Eastern notions regarding mind and matter, that there is no separation ultimately between subject and object, that all is one and all is mind in a sense. And also, Schrodinger discusses how ultimately you can't really, and this again is something that has been harped upon a lot subsequently, especially as regards the field of quantum mechanics, that you can't really separate the observer, the subject, from experimentation, from the observed phenomena, that ultimately everything comes to us through our senses, that we can't really conceive of a truly objective world without our own perceptions of it, in a sense. Um, and again, Schrodinger really seems to endorse the notion of a unified consciousness, that ultimately there is only one consciousness, and that our consciousness, our consciousnesses, as well as the consciousnesses of animals and such, are simply um, different manifestations of what is at base ultimately unified. And also, more than that, Schrodinger actually seems to at least entertain the notion that consciousness does not necessarily end in death, that because ultimately there is only one consciousness, that our individual consciousnesses may possibly, there is an actual chance, at least a non-zero chance, that consciousness actually may survive after death. Again, this is something that I just don't feel like you would get out of many scientists nowadays. I feel like a lot of scientists currently have kind of lost the level of imagination that Schrodinger demonstrates in his work here. But that is kind of the overall gist of the second half, Mind and Matter. It is Schrodinger talking about not only about science, but about philosophy as well, and the interaction between the two. In particular, he touches upon the way that Einstein's theories kind of interact with, and perhaps some would say clash with, the philosophical theories of Immanuel Kant. Um, it's all pretty heady stuff, but that's the section of the book that I found the most interesting, because it had the most kind of philosophical heft to it. Whereas the first section, the actual What is Life section, is very, very restricted solely kind of to the physical realm and not so much the metaphysical realm, if you will. But anyway, so that is pretty much an overview of What is Life, including the section entitled Mind and Matter by Erwin Schrodinger. So, being this is a work of science, not any kind of narrative work, my criteria for this just will not apply. And plus, I would not even dare attempt any kind of critique of this, because this is so far above what I am qualified to really, well, critique. But I will say this book, it says that it was written for the layman, I think. I believe it says that on the back of this or something, that it was written for the layman. I'm not so sure that actually is true, because there is a lot in this that I had trouble grasping. There's a lot of mathematical elements in this, especially as regards like wavelengths and quantum phenomena and stuff like that, which just, of course, just went right over my head, that I couldn't grasp. But nonetheless, even though this is very demanding at times, I found it quite interesting and ultimately a very fascinating read. So, you know, could I recommend this? I'm not going to rate What is Life, because how? But I do think that it has aged remarkably well, and it ultimately proved to be rather prescient, because it, like I say, prefigured the later discovery of the double helical DNA by Crick and Watson. So Schrodinger was actually ahead of the curve with certain things with this work, but it is very demanding at times. But nonetheless, if you're interested in science, or if you're interested in the way that science interacts kind of with philosophy and stuff like that, I could recommend picking this up. I think there is a lot of stuff to chew on in this. It definitely gives you food for thought, and ultimately, I just found it a very fascinating read, even though I didn't quite grasp all of it, and there was some stuff in here that they definitely went right over my head. But yeah, so What is Life by Erwin Schrodinger. Have you read What is Life? If you have, let me know down in the comments what you thought about it. whether you have agreed or disagreed with anything I've said here today. And if you haven't read What is Life, I could, like I say, recommend this if you're interested in science. Um, it probably would help if you have some kind of background in science, more than just like the high school level that I have. Um, but I think there is a lot to be gotten out of this, and definitely a lot to chew on, like I say. And as always, if you have enjoyed anything you've seen or heard here today, remember to hit that like button and subscribe. I would really appreciate it. And until next time, peace.